All right, ladies and gentlemen, what we have here for Wednesday is back to good old slope. And there's a variety of ways of requirements to find your slope. We've got from graphs, from points, from tables, and so on. So let's go ahead and review those really quick. And we're going to go ahead and start off with good old PowerPoint. Going to try and do it as quickly as possible. So what we have here is slope of a line. Sorry, I had to yell at my son because I'm recording. What we have, again, is the idea of rise over run. So in other words, when you have your 2 points, you just need to make a right triangle. And normally I would have the students do the rise first and then the run, because again, it is rise over run. We got uphill, positive slope. Same thing, use your 2 points to go ahead and make a right triangle, rise over run. This one's a little bit better representation of what I have students do. I would have students start here, and then count down, and then right. But again, negative slope, rise over run. Remember, fraction form to find your slope. Rise over run. We've got some special lines, rise over run. When you have it as a horizontal, your rise would be 0, and 0 divided by 3 or whatever would just be 0. And then this was our even more special one. When we had a vertical line, our run was 0. And again, the trick was if 0 is under the line, then it is underfined or just undefined. Then we progressed on. Let me go past this. The slope formula. The slope formula, again, is we need 2 ordered pairs. The 2 ordered pairs are already given to you on the assignment. Again, we go ahead and label it as x1, y1, x2, y2. When you have your information labeled, you just go ahead and work with the actual formula. You do your quick basic substitution. I always start with the y's first, so I would go ahead and ask students to write an equal sign and a fraction line, and then starting at the top, my y2 is already identified as -4, then I put my subtraction sign, and then my y1 is a 2. I do the exact same thing with my x's. The denominator, my x2 identified as -3, subtraction sign from the formula, and the x1 there. And again, you just go ahead and practice your 6th grade, 7th grade skills, and clean it up, reduce it, you get 3/2. That means the slope is 3 over 2. So in other words, if you had on the graph, the rise would be 3 and the run would be 2. The main difficulty that students had when you were dealing with your formula was accidentally putting the x's and y's in the wrong location, and that's why we tried stressing students, go ahead and remember to write down the formula. So with our quick substitution, the numerator, the numbers would be -6, subtract 2, but on the denominator, really want to focus on that x1 there, 7, subtract -5. Some students would not write it as 7, subtract -5. Remember, that really becomes addition, and you'd get a 12. Some students would say 7, subtract 5, and write a 2, instead of 7, subtract -5, which gives you a 12. Reduce it, of course. Negative slope means it's going downhill. Rise, or counting down 2 boxes, and run to the right 3 boxes. So again, really quick with your slope there. You can progress on. Remember, if 0 is under the line, it is undefined. So back to that quick idea of what the problems are. We talked about the graphs. We talked about our data points there. So we need to talk about the data table. So going back to this information here, it's very similar to what we've already done on the previous instruction with the increase and decrease. Now, it may be presented to you as a horizontal or a vertical data table, but it's the exact same idea. So if you notice, we're going to go ahead and talk about the increase. So again, it doesn't matter if it's presented that way or horizontal. You're starting with your x. So for my x, I've got -2, -1, 0, 1, 2. So this is all going to be +1. And then my y, 3, 5, 7, 9, 11, that's all going to be +2. And this is where some students got confused on how you actually write your slope. Remember, it's not left, right on this one. It's rise over run. My rise is y, +2, and my run is 1, +1. And then if we'd like to, we can go ahead and reduce that into be 2. The graph description, that would be uphill because it's positive, and since it is an improper fraction, it would be a pretty steep graph. And continuing on, -3, -2, -1, 0, 1, again, +1, 5, 2, -1, so this is decreasing, and it's decreasing by 3. So rise, which is the y, over run, which is the x. So this would be a downhill graph, reading left to right, downhill, and it would actually be pretty steep as well because it is an improper fraction. All right, let's see. Those are just ones again. Just ones again. Sometimes it comes out a little bit different. Let's say that you had a different problem where you had your slope calculation with your rise as a +6 and your run, for whatever reason, maybe it came out to a -3. So obviously we're just going to go ahead and reduce that, which would give us -2. But let's say it was maybe a -4. So we're still going to reduce it. It's going to be negative. 6 and 4 can both be divided by 2, so that'd be -3 over 2. So again, it is a negative. So it's going downhill, improper fraction, a little steep. Now remember, if it was a proper fraction, like let's say 1/2 or 2/3, that would not be as steep. That'd be a little bit more gradual. That'd be like a normal type of ramp, not climbing up a huge mountain type of thing. All right, should be good to go. Be awesome. Again, send us any questions if you have it, and we'll go from there.